So in problems where we have more than one trig function, as in number 8, instead of me plugging in x, say for instance, I will plug in x and y. And if I have sine and cosine involved, or one of them involved, what I usually do, this isn't the rule, it's not the law, this is just what I do, I will make sine or cosine be x or y. Cosine will always be x, sine will always be y, just because then it makes sense to our coordinate points. So I'm going to call y sine, and I'm going to call x cotangent. And again, those are just placeholders for me to work through here. I'm just substituting that in. So this looks like 3yx plus 2y equals the square root of 3y plus 2y. So, that's a little ugly. But I do notice that on both sides of the equation I have a 2y, which means that it's kind of evened out with that 2y, so I can just sort of cancel that 2y out like it never happened. And then I will do 3yx minus the square root of 3y equals 0. Hey, I should have you guys put your phones in the caddy, because I already see people playing on their phones instead of taking notes, and that's where grades go down substantially. I am in a position in this problem where I've got two variables. And in the past, you learned in your algebra, if you have two variables, you need usually two equations to solve, unless you can do some factoring. And in this case, I can do some factoring. Both of my terms here contain a y, so I can pull a y out of that. And then what I've done is I've just set up two separate equations. So y is 0, and 3x minus the square root of 3 is also 0. So I add the square root of 3, divide by 3, so x is the square root of 3 over 3. Are we okay with my work? I did kind of go through that a little bit fast, but I'm just doing algebra. And then I go back and think about this. All right, I got my y, I got my x, except for that's not really what I'm looking for. Y is the sine, so I'm really trying to find out when the sine is 0. And I'm also trying to find out when the cotangent is the square root of 3 over 3. So I know the sine is 0 when the y coordinate is 0, and that's here and here. On the right on the y-axis, on the left on the y-axis. And so my theta answers for that first part are at 0 or 0 pi. You can call that either way. It's the same thing. And at pi. And I didn't add anything to the angle, so I'll add my plus 2 pi k, plus 2 pi k. And then I'll move on to the cotangent. That one's going to be a little bit more of a thinker. So when is the cotangent the square root of 3 over 3? Well, that happens when we put either the square root of 3 over 2 over 1/2 or 1/2 over the square root of 3 over 2. And the square root of 3 over 2 over 1/2 would reduce down to just the square root of 3, so it must be 1/2 over the square root of 3 over 2. So that's my brain process going on here. So that happens when I put 1/2 over the square root of 3 over 2. And cotangent is cosine over sine. So that's when the cosine is 1/2 and the sine is square root of 3 over 2. So that's the pi over 3 family. And it's positive. So that is in the first and the third for cotangent because I have the two. It's either positive divided by positive or negative divided by negative. And so my answer here is first quadrant pi over 3 and third quadrant pi over 3. And that is 4 pi over 3. And again, I add my plus 2 pi k, plus 2 pi k. And k is an element of the integers. And remember from yesterday, cotangent and tangent can be shortened up. So I could do this here as just theta equals pi over 3 plus pi k. So I could write that as theta equals pi over 3 plus pi k instead of the two of these things. But again, that works only when we have it on exact opposites, or like exactly pi away. So this is an asterisk kind of thing. This is an or. It could be, this whole thing could be combined into that one answer. And that's a lot of work in there, and it's really scribbled up. And again, I apologize for the lack of room, but hopefully that makes sense. Okay, so that was our all solutions that we worked on yesterday. We're going to do just a quick refresher of one-lap solutions, which is what we first did, but our one-lap solutions are going to be on some more complicated problems. And I love to start with problems where you have to factor, because they show up a lot. Factoring problems show up a lot, and we get scared sometimes when we see them. So I'm going to do number 11, and I think there's one more that I'm going to do in there. But I'm going to do number 11. Number 11 is 3 equals 2 times the cotangent of theta minus the cotangent squared of theta plus 2. And so I'm going to rewrite this as 3 equals 2x minus x squared plus 2. And because I see an x squared in there, that tells me that I'm probably going to have to factor to solve, especially because I see the combination of an x squared and x. And so when I factor to solve, I use the zero product property, and to do that, I'm going to bring everything over to one side. And I added the x squared to the right because I always want my first term to be positive. If my first term is not positive, it's going to make my factoring very difficult, so I don't even want to mess with that. I like to make the first term positive, so I added the x squared over to the left. I subtracted the positive 2x over to the left, and then I subtracted the 2 from the 3 on the left, leaving me with this. Hopefully that looks good. Okay. And then I'm going to go ahead and factor this. And when I factor this, however you need to do it, if you're a snowflake person, that's the way I'll show it. But some of you can guess and check your way through this beautifully. That's how I usually do it. But if I snowflake it, it's 1 times 1. I need two numbers that multiply to be 1 and add to be -2. X and X go on the sides. And that looks like -1 and -1. So I really only have one solution here, and that's x equals 1. It just shows up twice. That is going to show its face, shine around again when we graph, when those factors show up twice. That's 2 zeros. And what that does when you graph is make your graph bounce off of your x-axis, but we're a little bit ahead of the game there. Right now, it's only going to be interpreted as one answer. And so this is, when does the cotangent theta equal 1? We've seen this many times before. Again, I hope you're getting comfortable with these things. We don't have a lot of choices. So if something looks foreign, you did something wrong, or we can't answer it. Those are our two choices. Go back and check your math. Otherwise, you're only getting the few answers. I think there's only 11 numbers that you could get for your answers. And so when is the cotangent 1? It's when the cosine and the sine are the same, and that's in the pi over 4 family. And when is it positive? Just like the tangent in the first and the third, because that's when the cosine and the sine have the same sign, S sine, G n sine, positive over positive, negative over negative. And so I end up with theta equals pi over 4, and theta equals 5 pi over 4. And unlike all solutions, I stop here. So it's one step less. My answer is done. The only time that that is going to change is when I have something in front of the angle, and we'll see that in action today as well. All right? So, any questions on that factoring? No? Feel okay-ish? You might not like it, but you think you can do it, hopefully. Okay. Let's do one more where we factor. So that's going to put me on problem number 14. One more where we factor. And again, I'll put y in for sign. You can do whatever you want, right? This is negative y minus 2 equals negative 3 plus 2y squared. And then I'm going to go ahead. If you want to do x, again, it doesn't matter the variable you use at all. Just if you have multiple things going on, you want to use both variables. All right, so I'm going to get everything on one side. This time I'm going to move it over to the right-hand side because that's where the y squared is positive. So this is 2y squared plus y minus 1. Again, I left the y squared alone. I added the y from the left over to the right. I added the 2 from the left over to the right. And then I'll go ahead and factor. And again, if I do my snowflake, it's front times last. The top is negative 2. The bottom is positive 1. My variables are y and y, actually 2y and 2y. Be careful. When you have a number in front, that always changes that front number. So I need two numbers that multiply to be negative 2, but add to be positive 1. Negative 1 and positive 2, great. Negative 1, positive 2. If you use the snowflake and you have a number in front, that means at least one of these things are going to be able to cancel or reduce. A lot of times people forget to do that reducing. It doesn't hurt you when you solve, but it does hurt you when you're just factoring in general. So my answer here is 2y minus 1 and y plus 1. And so 2y minus 1 equals 0 and y plus 1 equals 0. So y is 1/2 and y is negative 1. Are we good? Again, I cruised through that kind of fast. We okay? Did I do wrong? What? That's what? What did you ask?
He was saying that one on the bottom, the one on the bottom is supposed to be negative, but it's the line in the middle, not the one on the end.
Yeah, yeah. You okay with that? Yeah. That's, this one is the negative one. This one's positive one. Bless you, bless you. So I'm not solving for y, I'm really solving for sine. I want to know when the sine is 1/2. I want to know when the sine is negative 1. And the sine is 1/2 when we do, let's see, pi over 6 family, correct?
Yeah.
In the first and second. And the sine is negative 1 down here. So that's at 3 pi over 2. So my thetas are pi over 6, 5 pi over 6, and lastly, 3 pi over 2. And these were just one lap around the unit circle, so I am done with that. Okay? That's all I'm going to show on this sheet. And then I want to talk through the next sheet because it gives all the different things that happen, and I want to show you some of the differences when you write them. Okay? So again, we're done with this. That snow day kind of put us a little bit behind, and so we're going to kind of tone down some of the solving for now. But in this next section, is everybody good? I'm just waiting for everybody to get caught up. In the next section, on the next 2 pages, front and back, all it does is goes through and explains how you would solve. And I want us to look at just kind of separating what the differences between the two types of answers are when you read your directions, okay? So I went ahead and solved this one right away, and I think you guys are okay with that. the math was pretty easy. I subtracted 1, I divided by 2, I got cosine by itself, and I'm trying to figure out when the cosine is negative 1/2, and it doesn't matter what variable you have here, just know that whatever variable is here for your angle is the variable that you're going to use as your answer. And if I'm going only one lap around the unit circle, I know that the cosine is 1/2 in the pi over 3 family, and I know the cosine is negative in the second and the third quadrants. So this is pi over 3 in the second and the third. Oops, I don't know why I put an extra line there. Pretend like you don't see that. Okay, pi over 3, second and third. So this is 2 pi over 3. That's 1/3 less than 1 pi. And in the third, it is 4 pi over 3, and that's 1/3 pi more than 1 pi. And I stop there, so that's my solution. Done and done. But if they ask for all solutions, I add 2 pi k. And let everybody know that that just means here that I am repeatedly, this is the translation of this, I am adding 2 pi a number of times to get all of my answers, and the number of times has to do with the set of integers. I'm going to add 2 pi 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, etc. to positive infinity, and also in the other direction. Negative 1 time, negative 2 times, go backwards 1, backwards 2, backwards 3. And again, that's all that translation is. So just, can I get a show of hands, a show of feelings, a show of what you're going? How does this feel? Solving, are we okay? Anybody in the can't do it, not gonna do it, can't. Okay. All right. If you're feeling that and you don't want to share that, just please talk to me at some point and we can see what we can do to get things fixed. I did the same thing for this next one. Take a breath, lady, right? I just keep talking and not stopping. I went ahead and I solved right away, and you can write the solution on while I talk. I started by adding the 1, and then I divided by 3. And notice I didn't put a variable in for this, only because I'm feeling more confident in my solving, and I just kind of know how that works. So in my brain, I understand that it's a variable in there. And then I keep my tangent answer when I'm done. When I take the square root, don't forget, do not forget to use plus and minus. And again, sadly, I'm sure half of you still will. But don't forget to use the plus and minus. That makes my answers multiple. That means what I'm actually solving for here is, or trying to find is, when the tangent, oops, I want to do this. When the tangent is positive square root of 3 over 3, and when the tangent is negative square root of 3 over 3, and my angle that I'm solving for is x, and how many people know when this is without having to do any thought? You have it memorized already. Nobody? It's got the square root of 3 in it, so it's either when we do the square root of 3 over 2 over 1/2, or it's when we do 1/2 over the square root of 3 over 2. And this one is the pi over 3 family. That's when the sine is the square root of 3 over 2 and the cosine is 1/2, and that actually reduces down to the square root of 3. This one is the pi over 6 family, and that reduces down to 1 over the square root of 3, which, yes, does rationalize. When we rationalize, the denominator does get. So I'm looking at pi over 6, and because it's all of them, positive and negative, my answers are all of the pi over 6s. Every single one of them. So I am going to write down when it's positive, and that is in the first and in the third. And when it's negative, and that is in the second and in the fourth. And when I do all solutions, because these two things are pi apart, I'm just going to write that in my shortened solution as x equals pi over 6 plus pi k. And I'll do the same thing for this next one, x equals 5 pi over 6 plus pi k, where k is an element of the integers. And that will be where I end this with all solutions. Again, if you don't feel comfortable with that and you feel like, oh, I'm not sure I'm going to be able to remember that, I want to keep consistent, it's new, you could just do all of these with plus 2 pi k. And that's the same thing. This is just a more efficient way to write it. All right, so don't forget. All right, questions? Then our next. Then we threw some numbers in front of the angle. And we saw how this affected our all solutions. It affected two things. The actual answer for theta, because when I solve it, I solve for 2 theta, and I need to divide by 2 to get theta alone. But it also shows up in what we add on the end. And so that 2 changes what we add. I work with 2 pi, divide by 2, so I'm going to be adding pi k on the end when I do my all solutions. But when I solve, I'm trying to figure out when the sign is the square root of 3 over 2. And that is the pi over 3 family. And the sign is positive in the first and in the second. And so 2 theta equals pi over 3, and 2 theta equals, in the second, 2 pi over 3. So I need to divide by 2. Divide by 2 on both parts. And that'll give me my final solution. That means theta is pi over 2. No, pi over 6, I mean. Sorry. And theta is pi over 3. That 2 angle also affects the 1 lap solution as well. And that's because there are 2 signs that fit in 1 lap of the unit circle, because that's what the 2 tells me. Which means that for every answer I should get 2 answers. 1 for the first lap, 1 for the second lap. How do I find the second answer? I add pi. Why? Because again, it'll get me the second solution in the second sign that graphs within 2 pi. If this were 3, I would have to add 2 pi over 3, and I'd have to do it. So I had 3 answers. So the number in front indicates the number of answers. If it's a fraction, it'll cut down my answers. I can only pick the answers that fall within 2 pi. So my next one here is the same way. Plus pi puts me at great, thank you. And so those are my other solutions. And then I can go ahead and solve this. All of these, again, are within 1 lap around the unit circle, and then I can go ahead and solve this. And when I solve this, I do the first answer, pi over 6, plus pi k. And the second answer, pi over 3, plus pi k. K is an element of the integers. All right, up next, I have the factoring problems. And we did a couple of those already, so we're going to do one more. I did not go through the steps here. I like to put a variable in here when I do the factoring. It makes it a little nicer to work with. So I'm going to go ahead and factor this guy. I will set up my snowflake. So 2 goes on the top, -3 goes on the bottom, 2y and 2y. I need two numbers that multiply to be +2, add to be -3. They are -2 and -1. Oops. And this can be canceled, so that's y minus 1. So all my answers are y minus 1, 2y minus 1. And so y equals 1 and y equals 1/2. But again, I'm not solving for y, I'm solving for sine. So when does the sine equal 1? Pi over 2, great. When does the sine equal 1/2? It's in 2 places. Again, I'm looking for when the sine is 1/2. Yep, and that's pi over 6. When else? Beautiful job. Excellent work. Is there anything in front of the angle? No. So do I have to add more answers to this? No. Now I'll get my all solutions. X is pi over 2 plus 2 pi k, nothing in front of the angle. X is pi over 6 plus 2 pi k, and X is 5 pi over 6 plus 2 pi k. K is an element of the integer. So once I find those answers for my one solution, getting my all solutions is easier. All right, very last problem type that you'll see has to do with rewriting with identities. There are occasions when you are going to have a double angle mixed with a single angle, or you're going to have a cosine squared mixed with a sine squared, or something to that matter. And what you're going to have to do is rewrite it using one of the identities. And so I'm going to take a look at what my options are for identities. If I find my sheet, if you have yours, you can take it out. I don't know if some of you kept them or threw them away or what, but I'll show you what I mean. Where are you? Sheet. Yeah, so remember these? I'm going to focus on the double angle. The double angle, sine double angle can be rewritten as 2 sine cosine. So 2 sine cosine equals sine. And then you might be thinking, well, wait a second, how does that help me? It helps me tremendously, because now I only have single angles in here. I can't mix doubles and singles. I won't be able to solve that way. This has both sine and cosine. Well, we already did this earlier. Bring it all to one side, set it equal to 0, and factor if you can. It might be helpful if you rewrite this as 2yx minus y equals 0. And then I'm able to take a y out of both. So I took a y out of both terms because there was only one here. I had to replace it with 1. It doesn't just disappear. It doesn't make it 0. So when I do my solving, I replaced y for sine and x for cosine, just because that's kind of what they are. And so I'm looking for when the sine is 0 and the cosine is 1/2. And that's just me setting 2x minus 1 equal to 0. So 2x minus 1 equals 0. Off to the side. That's y equals 0 and 2x minus 1 equals 0. That one doesn't change. This one is when x is 1/2. And again, that's cosine is 1/2. So now I can do my answers. Yes, originally there was something done with the angle, but because we replaced it, we're solving for all single angles, which means my answers are going to be all single angles. So I found x's. This happens when x is, sine is 0 when? 0 pi and pi. Great. And cosine is 1/2 when? And you are spot on, girl. Nice job. So what are my answers? In all solutions, 0 plus 2 pi k, pi plus 2 pi k, pi over 3 plus 2 pi k, and 7 pi over 3 plus 2 pi k. And k is an element of the integers. Don't forget to do that. If you do forget to do that on your test, you will not lose all of your answers. That is 5 pi over 3, not 7 pi over 3. Sorry. I saw Henry's hand go up, and I realized it after I wrote it. And I saw faces make, too. Sorry. I sometimes hear what I want to hear. But we caught it in time. So, are you mad? Are you sure? Okay. Just want to make sure. All right. So, that's what we've got going on today. If you look at the back page, you will see that there are multiple equations. Try and get most of this on here. Multiple equations that you need to solve. Your goal, and you're solving them all for only one lap, so you don't have to worry about solving them for all equations. You're just solving them all for one lap. What you need to do is do any problems that you want on here and try to make it add up to 10 points. And so there are different combinations that you could do that. You could do 2 of the easiest ones and 2 of the medium ones. That'll get you to 10 points. You could try to do 2 of the hardest ones and only 1 of the easiest ones. You get it. I don't need to explain anymore. I know that you guys are capable of figuring that out. But you need to get 10 points. I know somebody's going to ask, if I do more, can I get extra credit? And the answer to that is no. However, if you do more, you can get credit added on to stuff that was lost. So it would guarantee you getting a 10 if you made a mistake on one of the problems. Let's say you said the sign is, the answer to this one is pi over 4, and so you lose a point, but you did an extra problem, I would add a point back on, so you could get closer to 10. So you can guarantee yourself a 10 by doing more, but all you have to do is 10, all right? So that is what you need to work on today. This is not a priority, all right? This I am not going to have due until Friday. So you'll be able to work on this again after your test tomorrow. This is not priority number 1. It's not going to hurt you to start working on it now, but it's not due until Friday.